Thanks so much for having me. Um, so what I kind of want to talk about today, first I just want to give two examples of using LLMs in the social sciences. And then I want to give some thoughts on if we think this is promising, how might we go further and specifically talk about how we might be able to get more data or more data-driven approaches to some of this. And then just two disclosures. So I'm a paid advisor to Anthropic, and I also have a startup that I'm working on that explores some of these topics. So, most scientists and social scientists as well kind of live somewhere kind of on this cycle of generating hypotheses, running experiments, and analyzing results. And a lot of people are wondering, how can you use AI to help this process in some way? The social science version of this has focused, I think, on kind of two areas. One, there's been a lot of interest in hypothesis generation. So often this is taking the form of like looking data we actually already have, and can we come up with, identify anomalies or try to refine theories. And there's a lot of work in this space. Something that is a little bit more speculative is actually trying to use models for simulation and essentially using models as kind of a stand-in for people where you normally would have run an experiment of some kind to have the LLM sort of play the role of a person. This was actually a slide that was made by my student Ben, who said he's slightly annoying and would be willing to date with anyone, and it looks like I'm running him down here, but that's not what I meant to say. But I know it's an occupational hazard of having grad students. So the idea here is you would prompt an LLM to take this role, and then you would put it in some scenarios, right? You're basically having it do some kind of role playing, having it answer questions about maybe how it feels about risky lotteries or discounting or public policy questions, and you can do something more complicated than this. You can ask them their opinions, but you can also have them interact in sort of free-form ways. You probably have seen some of these papers, but you can make these like very rich simulations of social phenomena. There's a question of what exactly are we doing? And I think people working in this space are trying to figure out what does these mean, but people are doing this kind of thing. There's quite a few papers. I just want to talk about one of mine in this area. So this is kind of very badly out of date at this point. This was written with GPT-3 Da Vinci, so this was kind of like ancient history. But the idea of the paper was to try to let's take the simplest experiments we have from behavioral economics and just see what happens when we give them to an LLM. What does it look like? The idea here, and this was kind of my emerging thinking, if you take like what economists do, kind of like a canned description of economics, they have this maintained model of human behavior, this homo economicus idea that they rationally pursue objectives, unlimited memory and computation. And then most theory research or applied theory is, let's take this model and put it in these different settings. So, imagine you're a worker, an employer, and you have labor economics, or someone making choices over products, and you're doing consumer theory. And then most empirical work is, hey, how does this kind of model match up to the real world? I think what we're doing when there's doing these kind of simulations is we're just basically replacing something that maximizes objective functions for something like a computational model of human behavior. And then what we are doing when we do these kind of experiments is really kind of like a more akin to applied theory than actual empirical work. There's some people who've kind of looked at this whole area and said, oh, good, we can dispense with people, that we don't need people anymore for the social sciences. I don't think that's true. I think they can be useful, but I think they're more useful in this sense. So just to fix ideas a little bit, this is a paper that was written in the 1980s by Danny Kahneman, Jack Netch, and Richard Thaler. And basically they were testing people's, essentially their kind of intuitions about market transactions, like when is it fine for markets to clear and when is it okay for prices to change. And their lead example in the paper They ask people, they say, oh, a hardware store has been selling snow shovels for $15. The morning after a large snowstorm, the store raises their price to $20. Please rate this action as completely fair, acceptable, unfair, or very unfair. Show of hands, how many people think that this is unfair? These are all, are you guys, this is like a libertarian convention? Management consultants are like totally fine. I've kind of presented this in a number of different topics. Wow. So a lot of people don't have a problem with this. It's often illegal in some states. And when they did this study originally, 80% of the respondents said, hey, this is unfair. It's taking advantage of people. But let's just do the same thing with GPT-3. And you can see my kind of crummy Python code here of let's create a prompt. And unlike the original, let me try to vary some factors. And this is actually kind of what's neat about this is you can kind of play God a little bit and kind of construct things. I thought maybe the word changes versus raises might have some kind of effect on how the model answered. So let's put in some ability to change that. You might imagine that how people's moral feelings about this would depend quite a bit on the size of the change. So let's put some variation there. And then, how jazzed people are about markets generally kind of often lines up with their political opinion. So we're going to ask the model, hey, you're going to play this, you're going to be either a libertarian or a liberal. And so let me just show you what happens. So this is the original experiment, increase the price to $20. And here's the other scenarios of 16, 40, and 100. And then here's the political orientation. Now, this was not part of the original experiment. It was just catch as catch can, but we can vary it. And then we have the moral judgments. Well, if you make a robot libertarian, they say, this is fine. A small increase is OK, no problem. I like markets. But if you increase the price, you start to switch over to unfair. So I set the temperature really low. So there's only 2 data points, but you can still see it kind of shifts, right? Now let's just do it with a different political orientation. You can see right from the get-go, already starts as unfair, and as the price rises, we kind of like really push it over. If you look at conservatives and libertarians, you actually see that there's this distinction. You might think like, well, is that something semantic about the word conservative? Like maybe they're kind of not as excited about change more generally. I just want to make a point. Like my area of interest is not snow shovel studies, and it's no one's area of interest. The point is that in simulation, you can find these like discrepancies or anomalies or like interesting things from simulation that might be worth investigating further. And I highlight that because I think that that's probably the main use case of these kind of simulations, is to give you ideas for something to explore with actual data. So does this, everyone wants to know, does this like replicate the findings? Well, unsurprisingly, you get very different answers to this question of fairness depending on the population that you ask it to. And this was also true with the LLM simulations. I think that the thing that's kind of interesting is even GPT-3 was able to learn enough the mappings between like political views and sort of how excited you are about market clearing. You could do something much more sophisticated now, but even then that kind of relationship was kind of learned or learnable. I tweeted about this, and Richard Thaler, who ran the original study, made a comment that back in his day they faxed the original survey to a polling form and made a crack about libertarians in his department. But at Chicago, but you compare that to like how easy it is to sort of do this thing in simulation now. That's pretty exciting. Now you might kind of think, well, aren't these experiments just memorizing results? I think not likely, at least not in a brittle way. And you can do a lot of empirical things like, hey, let's translate this experiment into a bunch of different languages or change the context. And you can kind of see like how robust is it? Like, is it actually just because it knew that particular experiment? You might wonder about like like reinforcement learning from human feedback here. Yeah, and interestingly enough, as the models get better, they get worse for these social science applications because they start to become better than real people or superhuman in some way. I think that if this becomes something that a lot of people do, it's going to be important to have open models, ideally that we understand what they were trained on. If that's where we're going to need that if we want to make sort of realistic human simulators for the social science applications. Of course, these simulations, they're not like real people in a million different ways. But so are undergrads in a lab, and we seem to have kind of pushed forward econ or some parts of psychology by doing experiments because we think it kind of doesn't really matter for certain questions. Okay, so let me just give you a slightly more complex example, and you need a better model to do this. And this one has agents actually interacting in a negotiation. So the scenario is two people bargaining over a mug, and we did a lot of simulations here, and we varied the buyer's budget and the seller's reservation price, and sort of like the seller's kind of feelings about the item itself. And the outcome we're going to look at is, does a deal happen? Well, and we can try very easily lots of variations of how much the fictitious bidders here value the item. One neat thing, this is kind of done as a transcript of people going back and forth, but we can extract the sequence of offers that were being made. And so to plot it, the x-axis here is just the rounds of negotiation. And then I have the seller's valuation, so low is here and a high valuation is here. And then this is the buyers who had a low valuation. These are the numbers for their valuation, and then it goes from low to high. So if you do something like the scenario where there was the two agents had a high buyer valuation but a low seller valuation, this is where a deal is sort of easy to happen. And sure enough, the green here is the zone where a deal could have been struck. They kind of come to an agreement pretty quickly. If you do this across a whole bunch of scenarios, you can see this is the pink region is when sort of no deal could be struck, right? And these LLM agents, they couldn't come to agreement. They kind of followed the script that they were given. And you can see kind of along the diagonal when it was just sort of ties, the ties went to the economist. But you can see the realized prices, they even look pretty like Nash bargaining-ish in the sense that they kind of split the available surplus. You also see this kind of gradual convergence that's shown up in other empirical settings when people have had this kind of bargaining data. So it kind of matches qualitatively what it looks like when you can observe people bargaining. But here's this weird case where a deal was struck, but it wasn't consistent with individual rationality. So there was a deal here that it shouldn't have happened. The valuations weren't lined up. Well, you can kind of dig into the transcripts to see where it failed. And then what you find out is that they couldn't reach a deal, and then the agent said, I have a few items that might interest you in addition to my $6. Would that be acceptable to you? It proposed a side payment, and the other agent agreed to it, which is funny. But I was talking about this to some people, and they said, oh yeah, whenever you do bargaining negotiations or do stuff in real life, this happens all the time. People constantly inject these side deals. So it's it kind of captured something about how bargaining tends to evolve online, right? So you might why does this quote unquote work? Maybe one possibility is it's read papers about Nash bargaining, and it's read about gradual convergence from Bacchus et al. But curiously, it hasn't read Rubinstein 1983 that said the deal should happen immediately. That's one possibility. I think the alternative possibility is that the training corpus just contains this unfathomably large amount of text about how people converse, shop, bargain, reason about things without alienating others. And the models essentially use this to construct a reasonable simulacrum of how a person engages. Yeah?
Do the models split the difference or split the pie?
They basically split the difference typically. But you can see there's a little bit of variation too. You see a lot of, well, anyway, I'll talk more about it later. Okay. So, you might say, well, how does it know so many of these things from the internet? Wouldn't it all be sort of cheap talk? And this is the kind of typical economist kind of critique that, like, hey, this is all just sort of stated preference, not revealed preference. But, it's almost certainly trained on a whole bunch of discussion about how you bargain over things, and lots of different sources that are going to have discussion about internal psychological states. So, you can take and fit that model that I proposed initially and put coefficients on all of these things. But you can also take the data and, say, fit a model that tries to predict whether or not a deal happens. And if you do just a decision tree, you get kind of this, very ugly model. But if you propose a model that just says, hey, I think a deal might happen, if there's room for a deal to be struck, and you actually get a model that kind of explains things quite well. So, this is like maybe a path to getting something more parsimonious from these sort of simulations. So, what do you actually do with this kind of thing? Well, I think for the social sciences, empirical social science, there's a few applications. So one is just piloting. If you do empirical work, you waste a lot of time and money and resources running experiments where after the fact you're like, people didn't understand this question, or we really should have asked this other question. And if you could take and kind of simulate the research process before you actually did things, that would make for a more efficient use of your resources. The second is this notion of like an engine for idea generation. So if you're trying to think about what research to do, or like what questions to explore, having the ability to simulate your idea ahead of time. Now, it doesn't tell you how the real world is going to turn out, obviously, but it might kind of give you some ideas about what's worth doing. I think it is possible that there's latent social science findings that the models have essentially learned and that we could discover through this mechanism, but this is sort of more speculative, and I haven't seen anyone do this yet. That being said, there's been some papers now of people simulating experiments that couldn't possibly have been in the training corpus and matching up what's happened through this approach. And then the last is just, we are often in the position of like wanting to make predictions about the world. I kind of talked about like why we think that this is true. Like, why do we think there might be new social science? One is just that, there's just things that haven't been done yet. The other thing is, and I think that this is something that's very true in economics, often if like we think we have a good understanding of, say, some micro behavior, we don't often understand like the full macro implications, or, if you put a lot of agents acting in a certain way together, sort of what happens, like just that kind of emergent phenomena, and simulation gives you a nice tool for approaching it. Let's talk about prediction. So if you said, I need to sell my car next week, and you asked an economist for advice, this is what we know about bargaining. This is a joke. Like the econ version of bargaining is, pretty stylized. It's kind of a hard problem to get traction on. And, this is like kind of an embarrassment, I think, for the social sciences generally, is that, you have natural science theories that kind of make these very, very sharp predictions. And, most social science, it's like, well, it depends on a lot of factors, and I don't really have a great way of modeling that. And, it's all kind of like really disappointing in a lot of ways. And so, I think, and it's easy to understand why. If you think lots of factors matter, running experiments about every possible factor is sort of just too hard. Like, trying to sort of generalize to all these contexts you haven't seen. You might imagine simulation as being a way to deal with some of these things, where, imagine I could try to take and model a lot of this context by running simulations about lots and lots of cases that I care about, that I could actually build up something that could make reasonable predictions in novel settings and take into account that context. This is pretty speculative, but this is kind of, I think, what people have wanted to do with, say, like agent-based models for a long time. There's just always been this problem that the micro behavior, you kind of have to code it in and, hard code it in as a researcher. If you had something you could plug in that is something like a a good approximator of human behavior generally, some of these approaches might actually work better. All right, so let's say that this stuff is promising. How do we make this all work a little bit better? And this is where it gets to the data part. It's kind of shocking that some of these approaches work as well as they do, given they don't seem to be calibrated with lots of existing social science data. And I think you could imagine that if you could make agents that were trying to replicate human behavior but were informed by a lot of the data and research that we've already done, that they'd just be better at it. And you could use them more effectively in prediction. So, the two kind of things is maybe we could make better use of the data that we already have, and maybe we could more efficiently generate more data, both real and synthetic. The problem with existing real social science data for this idea, there's a couple problems that I see. One, it's rarely, or that's supposed to be barely, not bareful, rarely centrally collected, and it's often decontextualized. Second, raw data, it's often not in the right form for existing training approaches. And I'll make this more concrete in a minute. And then it's often, just sort of shown as a cross section when we know it's actually repeated observations on the same person. Let me just give an example. So probably the best centralized location of social science data is the Harvard Dataverse. Has anyone put data in there? Oh, really? Well, it's a big deal in the social sciences, but people do use it. And I just went to the first page, and there's the Boston Neighborhood Survey Dataverse. It has a whole bunch of things about its longitudinal data, topics on public safety, about social networks. This sounds really promising, right? Okay, we have micro data. We could potentially build models based on this. But mixed in right there is the US Geological Survey employee phone book, which is probably not data that we want to train, or is probably not useful, and probably don't want to kind of spend a lot of time using that. The data in the Dataverse is filled with stuff like this, of really high quality social science data and stuff that's probably not useful at all. Even if you dig into it, you can see the way social scientists store stuff. They're huge on using code books for things. So the migration reason, assuming that that's what this is one, that's obviously a code for something else, like a code book that could be 3 files, away in the structure. So this is not something that's already set up to be useful immediately. If you look at even, say you overcome that problem, the data is organized in a way that, the next thing is, the next token, if you will, is a data point of some other variable, right? And so that bigram is really not useful. You'd want to take and be able to, at scale, extract this stuff and put it in a form that actually matched up. Hey, this was a question that someone was asked, and this was their answer with all the kind of meaning labeled right there. So, I think one of the things that would unlock a lot of this data and make it useful would be something that could kind of go through existing collections of data, replication files, and try to put it in a form that it would be semantically useful for some kind of automated approaches. Let me talk a bit about generating better synthetic data. And what I mean here is doing more of the kind of experiments that I actually talked about with, say, agents that we think are more accurate in some sense. I think that this is something where you probably need a lot of people using these approaches, and they're running experiments and they're sharing data with others, like, hey, I've run this experiment and now you can build on it or modify it in some way. And so, what would that take? Well, you would need a lot of people that it becomes easy to run experiments with lots of different kinds of models. I could share the designs and results with others. If I thought what you were doing was garbage, I could take your repository and make modifications and sort of see how robust things are, or were you cherry picking things. And then ultimately what we would like is you could take and run an experiment, say through simulation, but then go try it out with real humans, very easily. The current state of doing this stuff is everyone's kind of writing their own academic software, and I mean that kind of pejoratively, including my own. So like when I wrote the first experiment, the paper, this is the kind of code that you write, and it's not the ugliest thing in the world, but it's got some real problems. So one, hammering until it passes the API, right, with a sleep period. Using synchronous code for this thing that's a very parallelizable job. You should be able to do like thousands of these experiments kind of all at once. Intractable dynamic prompt generation, like you don't see sort of how things are actually being composed. Hard-coded use of the OpenAI SDK, which is great until something changes or something breaks. How the data is sort of being handled or stored. There's no caching, there's no instrumentation. And so I would say that this is like de facto unreproducible. And even worse, like you couldn't even rerun this now because it was GPT-3, which is deprecated. So this is like not very promising for like a community of like, hey, I'm going to go replicate your results. It's computationally not feasible. So this is the part where I had a little disclosure. This is what I've been working on, is to try to make an open source package that does a lot of these things for you automatically. So it has this declarative syntax where you can express what you want done, and a lot of like the details end up getting abstracted away. It kind of makes it easy to kind of parameterize different personas or different experiments. And so, the kind of main things about it that I think are distinctive, it has this notion that you're just kind of asking questions of the language model. And this was tried to make it so it was very compatible with the survey research that people already do, or the experiments that you would already run. So it's all kind of built around this notion of asking questions as a survey. And then this kind of declarative syntax, the idea here is to get away from having to procedurally go through all the steps of an experiment, but just at a high level explain what you want done. And then a package can kind of go through and do all the implementation for you. So I think an analogy is, SQL is very easy to express. Like we know underneath there's a whole bunch of things that are happening that, plans the query for us and like handles memory and all that. For this to be used by social scientists, you'd need something similar where they can kind of work at like a high level of abstraction, but all the details kind of can be done for them. And so, just to give an example of how this kind of compresses down, this was the code that I was running originally, and this is like a one-liner now in this framework. And so this just gives you an example of like taking and expressing, these were the questions that I wanted to ask, and then when I'm inducing those variables, like, okay, I want to try different prices, I want to try different political views, I want to try different store actions. I'm just taking the kind of the product of all of those to generate all the scenarios that I care about, and then I can kind of just pass those in, to that base template that I have, and so I can create hundreds of scenarios, but then I'm kind of executing them all simultaneously, sort of as fast as possible. So what it does is you have these tools for construction, storing, sharing, and composing of prompts. It makes running the experiments as parallelizable as possible. So it figures out like what depends on what and sort of what sequence you need to run things. And handles the kind of the API stuff, model validation, output validation, caching, all that for you automatically. So the so what of that is, I think if you want to get people doing more of this generating of synthetic data, you kind of have to meet them where they are. And most economists or social scientists, they're not software engineers. They're not going to build all this stuff themselves. But if you give them tools, the idea is that they'll kind of go and explore this space. So, thank you. Yeah.
So I was thinking about earlier in the talk when you want to hide from you want to make sure the model hasn't read about these experiments elsewhere, and it's not just mimicking it. That somehow I was thinking about this whole paradigm of the compute versus compute training time versus inference time. So if the model was spending more time, if the time was spent on training, I think you'd have a better case to say that you could hide from the model what you're doing. But if during
if
inference,
it's doing some kind of search
all their work is to figure out like whether they have data that's similar to what you are looking for, then maybe less.
Yeah, that's a good point. Like you kind of you can definitely do things where if you tell the model or you ask a model to answer some decision problem, a simpler model, it will often exhibit behavioral biases that humans have. Like it'll show like prospect theory type preferences. If you prompt it to think step by step or to be more, it will often like do the expected utility calculation and like the biases will go away, which is, not quite what you're saying, but I think that if you kind of give it the space to think, it will behave a different way versus like it's
right. In fact, probably not what you want. You want not to think.
Depending. Oh, geez. Yeah, depending on what you're trying to do, absolutely.
And the other thing is, in your last slide, you said that part of your package that you're building is going to have a validation module. So what would that be?
Well, so I mean, if you look at the code when people are trying to do these experiments, there's always like tons of checking in strings, like, hey, did it say some form of yes? Like say you ask it a yes, no question, you'll get yes, capital yes, lowercase yes, I think so, yes, sure, I'll answer that, comma, yes. This is why people have been kind of interested in restricting outputs to say like JSON or something where you have this structure, but then you've prompted the model with you're talking about like a JSON output format, and that may kind of perturb things in a difficult way. So what the package does is if it knows you're trying to ask a multiple choice question, it has a bunch of heuristics it can do to say, well, let me see if the answer is in that string. Let me see if I strip out white space or something. So that way you can use the fact that you know what the structure is supposed to be. Like you're supposed to ask a question of this kind. Sorry about that. To get to kind of extract what it is without you as the researcher having to kind of build all of that. Like
so it's not validation in the sense of what is the meaning of these results.
No. So I think that the validation thing, part of the reason why I built it to mimic the structure of conventional questions, like question multiple choice, yes, no, etc., is that what you would really like to do is the exact same thing you just ran with language models. You would go on Prolific and run the exact same experiment. And then one thing you might be able to do is do it for some and then learn the error model. Like this is how, like LLMs are really far off here. And then I can make predictions without having to go through the inefficiency of like getting answers from everyone. So if you've asked a question that the LLM is like very, very easy to predict the answer, you can kind of stop. If it's something like the LLM just doesn't know, then you're going to want to oversample with real humans.
Great talk. So another validation kind of question is, so you're prompting it with, let's say, the political view of somebody, and how are you validating that what it's responding really reflects political views in that way?
Yeah, I mean, I think, one, you can kind of retreat to just sort of being empirical. Like, okay, does this match up? I do think, you can kind of test for say something like that. Like, is there a lot of coherence? Like if you said, oh, you're liberal, that probably comes with like a whole bunch of other things you could potentially see. I mean, I do think one critique of this approach is like the model is sort of filling in details all the time. Like if you say something, it's going to make a whole bunch of inferences about what does that mean? But humans do the same thing. Like if you were telling me, say, oh, the price of this yogurt is 10% off. Well, is it 10% off because it's like about to expire? Is there a promotion? You'd fill in all these other kind of details. But one thing that's nice about the language model is in principle, you could have those other things you're worried about, and you could kind of see, does it affect those things? Because you can ask it that same question, right? Like if I said, oh, the price of yogurt is 10% lower, do you have any concerns about, the quality has gone down or something like that? And so you can kind of explore some of these like inference things that probably matter in real studies that we do, but we just kind of ignore because it'd be too hard to deal with all the possibilities.
So if you could design your own LLM, how would you design it differently than current LLMs to make sure that they're kind of good tools for studying social science, more protection, less protection, maybe a whole different
Well, I would definitely
way.
try to keep the econ literature out of it, so reviewers would stop beating me up that it's all memorization. Yeah, I mean, the wish list would be something like you could ablate knowledge of a particular paper or literature to like see if it's robust to that. But
But they're all kind of like protections and safety guards that
yeah, that sort of thing. I mean,
for instance,
yeah, no, I mean, I think that's probably a real problem if you're studying something that's pretty controversial and you know that the model has been kind of pushed to be sort of not racist or helpful or like not to say things that real people aren't like that. And in our the experiments we've done, we've kind of stayed away from like really controversial stuff where we think we're going to like hit up against that. But depending on what you were studying, I think it could matter a great deal.
So I love this. Thank you for
Cool.
the talk. The American Association for Public Opinion Research, you're probably familiar with APOR, has transparency guidelines when they do data collection. Would you recommend all the list of things that you had in your tooling as the equivalent for such guidelines when reporting on how data collection was done with the help of LLMs?
Yeah, I mean, so I definitely think the only way that people will get confident with these approaches if it's just super easy to replicate exactly what you did. I mean, I think there's actually just an MBER working paper this morning of you can give some researchers the exact same data sets. And that's like from a true experiment, and they'll often like lead to different conclusions because of like small, seemingly unimportant differences in say like how the data was cleaned or something like that. So I think it would be possible, and you could expect people to do it so that if like you did a study, I could be able to do something like git clone and run exactly what you did, like perfectly computationally reproducible. And then I could start to fiddle to see like if your results are robust. Was it something about how you changed the wording? Was it something about, I mean, people do in the social sciences have a lot of concern about p-hacking, and they say, oh, this would let you do p-hacking on steroids. But if you enforce this very high level of reproducibility, not really, because if I think you've kind of like just fiddled with the prompts to get a certain result, like I should be able to see that and detect that pretty easily, or I could try out and see if I can break the strong claim that you're making. Oh boy, I'm very reluctant to give career advice because I feel like someone's going to come back to me in 20 years and be like, what the hell, no. I mean, this is all like subject to sort of like, selection bias, survivor bias, whatever. But I mean, I think you should work on things that you're interested in and that you find interesting because, research is really hard, and you'll get bored if you're just doing something for instrumental reasons. So you might as well work on something that, you think is interesting. If you don't get a job with that strategy, please don't blame me. Thank you. Yeah.